we're going to containerize an ML application that does demand forecasting for a delivery service. If you're just getting started with Docker, then I suggest checking out my video on Docker runtime arguments, which has more of an introduction to Docker, and then hop back to this one. In this video, we're going to be skipping all that introductory stuff and moving pretty fast. I'll show you the Docker application, then we're going to hop into a Jupyter Notebook where I'll show some data exploration and modeling that I did, and then we'll come back to our Docker app and I'm going to extend its functionality using some runtime arguments, and also I'm going to implement a feature to be able to make predictions. This is really cool stuff and I'm excited to dig into it. I'm Alex, and here on ZazenCodes I teach full stack data science. Docker is an extremely useful tool for machine learning. And in this video, we use Docker to train a machine learning model in a way that's reproducible on many different machines and operating systems. By the way, I'm publishing video walkthroughs of my notes over on Patreon. And just last week, I uploaded a 53-minute audio-video walkthrough of my slides on the book Fundamentals of Data Engineering. So if you're serious about learning full stack data science, then you can head over there and check it out. You can also sign up for my email list to get access to my Second Brain notes repository on Notion. I only send one email a week when I post a new video. Here's what my Docker application looks like. So I'll start by opening up Vim, and we're gonna look at our Docker file. We're starting from an image of Python 3.12. We're moving to an app directory. I'm copying my requirements in and then installing those. Let's go ahead and look at what our requirements are. We have scikit-learn, pandas, and numpy. And notice how I'm setting the actual versions of these so that we can do things in a reproducible way. Then I'm setting 2 environment variables. You'll see these later. And then I'm copying my scripts in here, but I'm not copying my source code. So scripts is a folder, and we're gonna have this train model function, which I'll talk about now. In here, if I go to the top, I'm importing my library, which is my meal demand forecasting, and we're gonna walk through these files soon. Then I have a few Python libraries, which I'm importing, and these are those environment variables that I set in my Docker file. So I'm reading those in so that we can use them down later. And specifically, I'm creating a configuration. So if I look at this config object, I'm importing this class called config. And so if I type GD in NeoVim, I can go to the definition of that. And this is my config class. And this is in my domain area of my application. So if I look over on the tree, I can see this is in a file, a folder called domain. So let's hop back to my train model where I was in and look at what this configuration looks like. So I'm setting a seed. This is for reproducibility. If I just hop down, you can see that I'm setting the random seed with numpy so that every time we build our model, it's building in the same way. It starts from the same random seed. But I have a data path, I have models path, and this is defining where we're going to be getting our data from and where we're going to be saving our models to. Then I have some information about the model, like the ID and these parameters. And if I scroll down, I can see this is the data that I'll be loading, we'll be working with. And I'll explain this later when we do some data exploration. But for now, I want to focus on the Docker component because that's the purpose of this video. And the target feature is the number of orders. We have some numeric features, and then I'm defining some features which are going to have to go through a transformation called one-hot encoding. So as I go down, we're gonna see how this application works. And this is everything that happens in our application when we run train model. We first load the data, then we do some feature engineering to create these time series features. Then I create my one-hot encoded features, and then I define my feature columns, and I feed that in to a train function, which will train our model. So lastly, let's go to my README. And I have some commands for building this and running it. All right, I've got my keycaster going here. So what I want to do is copy this code to my clipboard, and I have a shortcut in Vim that does that. And then I'm going to open up a new pane, and actually I want it down below. And if I say Docker version, I can see that I have Docker running. And so I can just paste this in order to build this. What it's going to do is it's going to pull that Docker file for the Python image, and then it's going to install my requirements. And since I've already done all of this, it ran really quickly, but for you, it'll have to pull these things and install everything. Next, we want to run this. So I'm going to copy my run command. But first, let's talk about what's going on here. We have 3 volumes that we're attaching. The first is for data. So if I hop over into my sidebar and open up my data, I have some Kaggle data, and it's just not showing there because they're being ignored by Git. But if I go to data and look at it here and go into Kaggle and list it, and what I want to do, yeah, I can see how big these are. So what we're doing here is we're using this fulfillment center, meal info, and we're combining it with this training data set, and then we're going to be training our model based on that. I also am attaching a models folder, and this is where we're going to save the models that come out of our Docker application. And lastly, I'm attaching a volume here, which let me just bring this out for you, for meal demand. So this is a really cool step where we're attaching our library as a volume. And what this means is that we can make changes in here to our code without having to recompile our Docker image. So if I was to go into prep load and say write a change or change my parameters or something like that, I wouldn't have to run this build step again. I could just go ahead and run it again because it's not baking that code into the model. It's just attaching it as a volume. So this is a really handy thing, and I'm always doing this when I build things with Docker. Lastly, I'm running the meal demand service, and I'm running the command for Docker as train model. And if I go back to my Docker file, you can see I have an entry point as Python. So it runs Python and then whatever you pass as your command. So let's go do that, and I'll show you what that looks like. I'm gonna go back to my README here, and I'm gonna copy this code, and we're gonna run down here and paste it in, and let's run everything. So while that's running, I can open up my Docker desktop. The image is called meal demand, and you can see how it's working here. And now if I go to my containers, you can see that it's running. It started 15 seconds ago, and I can open this up, and we can actually see the logs from it. Those logs are going to be matching the ones in my terminal. So you can see stuff like the files that it's loading, and then these encoders that were saved. There was some filtering that was done, and now it started to train my model. And this is the step that's going to take a little while. I can also look at my environment variables, and remember this data path and models path which we set? This has to be set to the path inside of the Docker container. So if I go into exec, this takes me inside of the Docker container, and by default, I end up in this app directory. So if I look at where I am, it's this app. But I could go back and have a look at everything in my root directory. And from here, I can see that there's a models folder. So if I look inside of here, this is all of my one-hot encoded binary artifacts which are existing inside of the Docker container. But because we set these up as a volume, they're also being linked on our system. If I go back a little bit and then I go into models here and I list what's going on here, I can see those same models on my computer, on my system. And these are accessible to me outside of Docker. I can also go into my data and I can look at that, and you can see that I have this Kaggle data which I'm loading. I can see some data, and let's see if I can even open it up. Center info.csv. That's not working. Okay, maybe I can open it with Vim. Yep, that's so you can see we're limited inside of our Docker image, and it didn't help that I just installed the slim version of Python, so it's a very minimal environment. What I could always do is just print the head of this. Cool. All right, so this is that dimension table that I was talking about for the fulfillment center information. Hop back over to my logs, and we can see that it's still training. So I will be back with you when it's done. So we can see that our model's completed training, and it's putting out some information here. I've given it a model ID, and then it's been counting down the time, although we weren't able to see that with our logging view into the Docker image. And then it completed training. So that means there should be a model in this folder right here. So if I list all these files, you can see this one, gbr_36a5d.pickle, and this is our model ID here, and this is our model, which stands for gradient boosted regression. So if I wanted to make a prediction based on this model, I could load this artifact file in, and then I could use that to predict on future data samples. At the end of this video, I'm going to extend our application to be able to do that prediction. I'm going to open up my Jupyter Notebook, and let's walk through that. I recently got some feedback that is too bright, so I started using VS Code for my Jupyter notebooks, and they're great. So this is my meal forecast development notebook. The first thing I do when I start working on a new data set is to look at it. So I'm just printing that out in the terminal inside of my notebook, and so I can see the center IDs in this data set, which are being mapped to city codes, regions, city centers. This is the place from where the meal is distributed from. And then we also have a dimensional data set on meal information. Like I was describing earlier, we can see like soup, Thai, rice bowl, Indian, stuff like that. And now we're gonna load this data, and I'm loading it into Pandas data frames. And I can look at what the training data set looks like. You can see in here we have these meal IDs and these center IDs. And this is how I'm joining the data on those dimension tables. So I do those joins using pd.merge. And then I can plot a bit of data and sort of look at it. The first thing I notice is there's 3 different center types. We're gonna take advantage of this soon and extend our application and use runtime arguments in order to pick out the center type and train different models for each of these. Pretty excited to do that. I have a few histograms, and one interesting plot I've done here is a heat map of the correlation coefficients. And so along the horizontal axis, everything is perfectly correlated with itself. And then the brighter the color, the more correlation we have. So you can see something that pops out at me is like homepage featured and email for promotion have pretty strong correlations to our target variable here, which is number of orders. So these are clearly going to be important variables for our model. So I keep doing some exploratory analysis, and then I build my features. And I like doing this in the notebook because you can really get your hands on the data and play with it. You wouldn't want to hop into Docker and start building your model in there. An environment like this is perfect, right? So I'm doing some orders just using a shift function on a group by set of data. So I'd love to make another video talking more through this exploratory analysis and how I engineered these features. And if you're interested in that, let me know in the comments. But also specifically, like, what are the pain points that you experience when you're doing exploratory data analysis or approaching a machine learning question? And then I can try and speak to that. And lastly, in my notebook, I'm creating my model, and I'm using a boosted regression tree. I'm using the gradient boosting regressor. This is similar to the concept of a random forest. So you could start there if you want to look into this and research how this works. Again, this would also be a topic for a whole other video. But the point is that it's a regression technique that's non-linear. My first thought when doing this is that I need to get my variables into a way that's appropriate for the model. So I want to determine what's a numeric feature and that's okay to feed into the model, and then what are features that should be one-hot encoded. And I want to be careful not to feed in numeric features that represent ordinal information where they shouldn't. So even though in my case I have these city codes, which I could feed directly into the model, I don't like to do that because there sort of is this concept of ordering with the city codes. You know, if I have code 57 and then code 37, and the model could learn some interpretation of ordering if I feed that in directly. So that's why I take that kind of variable and put it through a one-hot encoder. There's also other variables that I'm one-hot encoding, which are a lot more easy to understand, like cuisine. This is a string value that can't be understood by the model unless it's turned into a feature somehow. So if I just look at my numeric features, this is after feature engineering, and you can see I have all of these shift features and rolling averages baked into my data. And then these are the features which I'm going to feed into my one-hot encoder. And on the other side of that, you can see how big it is. There's now 110 columns because they've been one-hot encoded into this sparse array. Next, I'm just combining all of these into a training data set, which looks like what we have here. And then I'm doing some modeling. So I'm defining some parameters and I'm training some models on those, and I'm looking at the errors that we're getting out of that. And then I'm doing some k-fold cross-validation in order to do this properly and get some proper error metrics, but by not overfitting the data. And then the last thing I'm doing is actually making a prediction. So I picked out a specific meal and a specific center and plotted what the demand looks like over time for that. And now what I do is I make a prediction and I put my prediction on that plot for the next week. And here, empirically speaking, it looks like it's within expectations. So let's hop back over to our model. Let's go through each of these steps and see how they work. I'm going to start with the data prep phase, and we're going to look at the prep load. So we'll go to the top, I'm loading some data here, and what I do is I load these 3 files. I have some center info, meal info, and train raw, and we'll see in the exploration section how these all go together. But in this case, I have to merge these. So I have a merge function, which is doing that. And this is very basic. We start with like a fact type table, and we bring in some dimension style tables for the center information and the meal information. This refers to the center of like where the meal comes from for the meal delivery service, and the information about the meal is like the type of cuisine, or if it's a beverage or food, that sort of thing. Let's actually go to our train model, and we can see the next step is this feat ts. So if I do gd, again, I can go to the definition of that. And now I've opened a new file in my feat.eng folder called feat time series. So these are engineering some feature time series variables. I'm not going to go too deep on what's happening here, but the basic idea is that we're taking information from the past and assigning it to the current data point or the current record that we're trying to make a prediction for. So when we're trying to predict how many orders there's going to be next week, I want to inform the model of how many orders there have been in the previous 4 weeks and in the previous 16 weeks. And I also think it's valuable to tell the model how many orders there were 52 weeks ago. So the same week from the previous year. And I also have other similar features about the rolling averages from the same time period of last year. So that's all we're doing here. And I'm simply just adding in those features here and then returning that data frame to continue being processed. Now, if I hover over this function and I do gr, I can see all the places where this is referenced in my code. And specifically, I want to hop back to this train model function and see what's next. So now we're prepping our one-hot encoded features. This is a whole other aspect of machine learning, and in our case, we're taking variables which are a mix of strings and digits and converting them into these one-hot encoded variables that our model can use to train on. So again, let's go to the definition of this, and we can see that I'm in my prep OHE file, and I have a function here which creates these one-hot encoded features. And then it adds these one-hot encoded features to our data. And one interesting thing I'm doing here is I'm actually storing these encoders. And for this, we're going to be making sure we use a Docker volume. This is similar to storing our model. Because we're training encoders based on our training data, we need to keep those as part of our model artifacts. So we'll see what those look like when I run this code. All right, let's hop back to my train model and see what's next. We're just defining some feature columns, and this mostly comes from our configuration, but we're also spitting out some one-hot encoded features, which we're going to need to sort of return from that function in order to track those. That step creates really wide data. So whereas before maybe we were sitting around 15 columns, after one-hot encoding, we're going to be at like 100 columns. And I'll show some examples of what that looks like. But the last thing I want to do is go through a filter stage. So I have this prep filter, and I can hop over to that. And what I'm doing here is I'm just dropping a bunch of rows that have missing data. These rows in our case were introduced when I did the feature engineering. So that's why I'm dropping these after doing feature engineering. All right, let's go back to training the model, and I can see that finally I'm calling my train function. I'll go to that, and in here I'm taking in a data frame, my feature columns, and my configuration. And what you see here will be really familiar to you if you've seen scikit-learn before. We're grabbing our features, we're grabbing our target variable, and then we're training the model, fitting it based on this data. After training the data, I logged some training metrics, so the mean squared error of our predictions on the training set. And then lastly, I store the model. So here I'm referencing the model path, which I defined in our configuration. And then I'm dumping it using this function dump, which I import up here from joblib. Now, I want to focus on extending our application. If I look at our data, I have these 3 different center types. There's type A, B, and C. And I want to imagine that we're going to create completely separate models for each of these centers. So when I run my Docker application, I want to be able to specify the center type and then build the model specifically for that data. So let's do that using runtime arguments. The first thing I want to do is document our intended functionality. And I'm going to say train model for center type, e.g. type A. And now I'll just grab this code up here, put it down here, I'll get rid of this, and at the end I'm going to say train model, and then I'm going to have an environment variable, and I'll say -e, and I'll say center type equals type A. So where do I want to implement this environment variable? I want to go into my train model function, and then I'm going to grab it up here where I'm doing my other model variables, and I want the center type. So I'll say the center type, and we'll say equals os.get env, and again, I want center type like this. Now in this case, if it's not defined, I'm okay with that. So I need to make the functionality such that if it's defined, I'll train on that center. But if not, that's going to be okay too. All right, so where do we want to include this in our code? Let's go down here, and I could put that as a config variable. So right here, I'm going to say center type, and I'll say this. And let's keep in mind that at this point, this could be none. Now I want to go to my domain config, and down here, I'm going to put center type. And this is going to be either a string or it's going to be none. I have to be careful about that. Now if I go back to where I was, I'm bringing that in here for my center type. So now I have that available everywhere in my application through my config object. I think the next part I care about is probably when I load the data. I mean, that would be the easiest place just to get rid of the data we don't want to look at all based on our center type. And specifically after I merge the data, I could have a new step here, and I could say df equals, and I'll say center type filter, and I'll put in my data frame here, go down to merge, and let's create a new function. And I want to bring in one pandas data frame, and I also need my, let's call it center type again, a string, or it's going to be none. So if center type, let's say if not center type, then I'll just return the data. And else, what I want to do is say df equals, and I'm going to look at our data again to remind me of how this looks. So it should just be called center type like this, right? Okay, so I'll say df.center type equals center type. Cool, and then I will return the df like that. Actually, it's I think a little cleaner if I do it this way. And then I'm just going to make sure I'm explicitly saying that I do return a data frame from this method, and that's going to be called right here. And I'm missing my config.center type, which I needed to pass in. And now this should be working pretty well. It's a little mad about this line here for some reason. I don't really care about this error, so I'm just going to say pyrite ignore to get that out of my face. And we'll hop back up here. So the next thing I might want to do is set my configuration differently based on this. So up here I have model parameters, right? But in reality, I might want different model parameters for my model ID. So what I could do is something like this. I could say model params, bring them up here. I want to get rid of that, bring that down here, clean it up a little bit. Okay. And now what I want to do is actually have this as a dictionary for each center type. So there's type A, and this could be for type A. And I gotta close that, and let's just format this up. But then maybe I want different parameters for the other center types. I mean, that would kind of be the whole point of training separate models, right? So I could have type B here, and then down here, lastly, I could have type C. So how would you want to use this? Well, in our Jupyter Notebook, we'd want to be testing different models and finding the ideal parameters for each of these center types, for each segment of the data. And then based on that, we could tune these parameters. So maybe this one has, you know, a faster learning rate. Maybe this one has less of a max depth to avoid overfitting. Maybe this one we can extend the max depth a little bit more, and that sort of thing. Down here, I need my model param, right? So it was model params equals model params, and we'll put our center type in here like that. Now at this point it's mad because center type might be none, and this is valid. It would fail in this case, so this is wrong. What I want to do is I could call get, and then I want some default, and I'll call that all. Okay, so here's how that's going to work. Let's hop up here, and up here, and then I'll say something like all. And this will be the case where we don't pass a center type and we want to train all of them together in one model. I'll grab this code here. I need to get rid of that, hop down and get rid of that. And this is going to be my case when we're training all of them together. Cool. So you can see how the linting I've set up is really helping me. For some reason, it's still mad about this, but I'm really happy with what I have here. So I'm just going to ignore this too. Okay, cool. I'm pretty happy with everything at this point. I'm trying to think if we need something. Yes, when we train our model, we're gonna save it, right? And so I need to make sure I'm saving it properly. So here, when I define the name of the model, I don't wanna overwrite the model for all of them or overwrite each other, right? I need to distinguish these. So I'll say config.center type like that. And you can see my linting program is not giving me errors because it knows that that is in this configuration object. Because of how I've defined it, if I go over here, I have center type right here. So it knows to expect that, which is really cool. So if I go to my old files and hop back where I was, go to the bottom and center that, maybe the last thing I want to do is add a little bit of logging. So I could say the center type equals config.center type, and put a little guy, a little one of those in here, hop back, and where else am I doing logging in this application here? I've completed my training, and I suppose this would be a fair place to put this. I gotta F string it, go down here, go to the end as well, pop that in. I didn't put a space, do that. Cool, and that's fine enough for me. I'm happy with that. You could imagine extending this further, and you would want to in practice, but for our purposes, I'm really happy with this. Let's see how it works. I'm gonna hop down here and I'm gonna rebuild it. Why am I rebuilding it? That's because I have changed my file, which is my scripts file. I've changed this train model file, and this is not loaded with a volume. This is baked right into the image itself. So I need to rebuild everything so that this is updated. And now I'm gonna try and run this. So I'll go back to my README, and this was the specification that I wanted to do. Let's see if I can go ahead and run that. There was a little error in here. I'm gonna throw in right like this, and now this should work. I'll go ahead and update it as well in my README. And we're off to the races. It has started training for center type A. So this should take about 25 minutes, and while that's running, I'm just gonna keep building. What is this? I'm gonna get rid of that. What do we wanna do? Well, I have this script for training my model, but with all this training, it doesn't seem like I'm doing very much. I wanna make predictions. All right, so let's write a new script for making that prediction. I'm gonna copy this and paste a new file. I'm just gonna call it predict. And we'll open that up. I don't need to be training anything. I don't need to be doing any of this feature engineering, so I can just kind of strip that out right away. I do care about my data path. I do care about my models path, and I do care about the center type. I don't care about these model parameters, but I need a config. And if I come down a little bit, I shouldn't need to set any random seed if I'm making a prediction. So I don't care about that anymore. And in general, I just don't want to be following any of this. But I'll say completed prediction. And the model ID, I could go ahead and print. Now, my model ID is something that I'm gonna also need to load in somehow, and I can take that as an environment variable, and that will definitely be required. So let's set this, and I'm gonna use Vim to say models, if I can type, thank you. And I'm gonna call this one instead model ID. So in this case, we're taking this in as an environment variable, and it's gonna be required. So that should kind of cue us off. Well, do I wanna put this in my Docker file, you know, where I'm specifying these ones? Not really, you know, I wanna do that at runtime. So let's document that functionality. I probably should have started with this, and I'll say make a prediction. Okay, I'm gonna be doing some similar stuff here. Remember, we don't need to rebuild it. That's the whole point. I don't want to have to build a new Docker image to make a prediction. I want to use the same one that I've been using here. I do want these volumes. I do want our app data as a volume. And I might want to define the center type in here, but I definitely need to specify the model ID. And I'll give an example of that. And what I can do is hop over to my models, and let's just grab one of these IDs. I have this FB1. I'll paste that in here. Let's get back to everything. And this, you know, is kind of optional, right? So I want to sort of indicate somehow that that's like an optional thing to do. And I'll put it underneath that. And here we said predict was what we were interested in doing. This is almost what we want, except this would kind of assume you're making a prediction on what exactly? Like everybody? Maybe that's not what we want to do. Probably we want to make a prediction for only like a specific data point. So what did I do in our notebook? Well, I made a prediction for just a certain combination of a center and a meal. And in this case, what did I use? I used center ID is 177 and meal ID is 1445. Okay, I'm kind of tempted to make it an argument. So let's see how that would work. So I'm gonna say, and what I'll do is I'll just paste this nice little shortcuts for this sort of thing. And I want to keep track of these numbers, like as an example, right? So that was 177. Oh God, okay, let's go, let's go. There we go. Okay, this is exactly what I want. This is how I want things to work. So now that I've decided how I want things to work, I better make it such that it works this way. Let's go over to predict, and I'm gonna make sure I parse these arguments. I do not want any sort of model ID here. I want to keep that around for later, and I'm going to say starting predict like that, and I can pass my model ID, and let's do my arg parsing. So I'm going to import arg parse, and I'm going to say parser equals arg parse dot argument parser. And I am very sad I'm not getting any completion for this. Aha, okay, it's because of that there. All right, so parser.add argument, still not getting anything. Oh, okay. Center ID, and there it is. Okay, we'll say the center ID to predict. Whoops. I can't see what I'm writing. Predict demand for. And we'll do another one, but instead of the center ID, we're gonna do, I need S for search, and we're gonna replace this with meal ID. Okay, and then center is meal. Okay, cool. Then we're gonna say args equals parser dot parse arg. So now I have access to these as arguments, and I can do things with them. Now let's deal with our config. I'm at the point where I'm thinking I bit off more than I want to chew, but I don't think I can turn my back on you guys now. So let's just keep pushing on here. Okay, I don't really want to seed anymore, do I? This is where I'm starting to get bothered, because now these things that I don't need to define, I kind of have to say, well, or you know, they could just be none, the way that Python type hinting works. So I guess for now, I'll just keep on doing that, and we'll see how far we get. So I don't have a seed. I do want my data and models path. I do want my center type, but now I don't need model parameters anymore. So let's go back, and I need to make sure that those can be none as well. So that's none. Okay, let's go back again. What else do we have? So I need to know where my data comes from. I do care about my target and my features. So actually everything else can stay the same. And this is a global now. And now we need to make our predict, right? So I actually want to know what I did to train my model at this point. I kind of might need to do actually some of the same things here, which I didn't think I would. But let's see, over my train model at the top, I actually do want access to these things. And let's see, I do need to load my data. I do need to load my time series data. So I need to do all this same feature engineering, right, in order to make a prediction. And I also need to filter it. So all these steps have to remain. But instead of training, here's where I want to do something different. Here's where I want to do my predict. And what I can do inside of here is say predict and go back. And this is going to be where I want to focus my efforts next. So over in ML, right here, I'm going to copy this and paste it into predict. And we're going to update that to be able to make our prediction. But, oops, nope, but, okay, whoa, okay, right. Okay, but firstly, let's just go down to what I just wrote. I'm passing in a data frame, feature columns, and config. Happy to do that. I think that's exactly what I want to do. I don't know what that is. Let's go over and do this. So I have my predict file in my ML folder, and let's get to work on this. Instead of train, I said I need to do predict. And I'm going to say predict next week demand. And then in where I'm dumping here, I need to instead load. And we'll have to make sure I'm doing something with that. Let's see if I can get any hints on this, how it works. Okay, cool. So reconstruct a Python argument from a file persisted with dump. That's exactly what I want to do. And I'm assuming I'll be able to load things in a similar way to how the API works for dumping them. So we'll just see how that works when we get there. I'll say started, predict, completed, predict, and in here we gotta say let's say log prediction metrics. Go down to where I'd said that, replace that one. And okay, we'll see how that all goes. For now, instead of train, I want this to be predict. Okay, we'll go down here, grab that. All right, and I don't want to mess with this. Let's focus on one thing at a time, and let's focus on this. Okay, how about these guys? Well, I don't want these to be my features anymore. I do need to use these feature columns, but I only care about a specific part of the data, right? So maybe I can define an index or something. Let's see how I did it in here. Okay, so let's grab some stuff from my notebook. I had this line, which I'm interested in. And the next line I care about is this, and this will get me down to one sample, which is exactly what I need. I need to know this kind of max index week, and that might look something like this. All right, so what do we have here? I'm trying to create this kind of index, and I'm going to call it df.centerid equals config.centerid. Okay, and let's be careful about our brackets. So what we're doing is creating a series right now in pandas, and then I want to combine this with another series. The other thing that I care about is the meal ID, right? And I'm just going to grab this here and go to the end, paste that in, and here we want config.mealid. Great. Okay, one last thing that I need to get sorted is my week, and I'll say df.week equals 145. And this is, I'm like hard coding something here, which I just don't feel comfortable with already, right? So I want to say config.maxWeek. This is something that would be more difficult in practice, but for us, we know that the max week in our data set is 145. That's this week here. And I'm making an assumption that that's true for every center in meal ID. Of course, you could do some kind of query to get the max for each, and that would be a much better way of doing this. But for our purposes, I am very happy to do it this way. And I'm just going to go to the bottom and add max week. This is going to be an integer. And then over in our predict, not that one, but this one, it's mad at us now because I'm not defining the max week, but I can do that right now and say 145. Great. All right, back in the config function that we were working on, I seem to be doing this. I do like this naming convention of max week index, but I don't know. Let's use this convention. And now what I want to do is grab just that record. And I could even say logger.info and say making prediction for, and let's put X in here. I need to do an F string here. Now, I don't want any sort of target. I don't want to fit anything. I want to predict. And instead of defining it here, I need to load it. So I need to say load model. And we're going to have to make this function. And this is going to be similar to storing the model. So I'll just go ahead and replace this. But we're only going to take in our config. Let's pass that. Okay, and come down here. Now, the name can be the same, and the path is going to be like this. And actually, all this path should work quite well. But now I want to say reg equals load. And load is defined up here for my job lib. And I'm assuming that I just need to pass the file path in. And then I load my model here, and I can say model loaded. Last thing I want to do is return my regression model, and I'm going to say that that returns my gradient boosting regressor. Let's go here and paste that in here. Okay, cool. So that's being loaded. I'm making a prediction with that. I don't want to return that. In fact, I maybe don't need to return anything, but I don't know. Let's do it this way, and I'm going to return the prediction. So I'm expecting not to return this, but I want to return a list of floats because it'll kind of assume that we're making predictions for multiple records. And so this will be a list. We want this to be y pred, and this is just overkill, honestly. Let's just get rid of that completely. I've done my load model, so I'm not running anything like this. And actually all I want to do is say logger.info, and I'll say in here, predicted number of orders, y pred, like that. I'm getting a few errors here, which I'm not really sure about, but at this point, I'm ready to test this. And I'll probably learn some errors and we'll have to do a bit of debugging, so let's just see how it goes. Now, do I have to rebuild? Yes, I do. So I'm gonna look for how I built that, and I'm gonna rebuild it now. That went okay. Let's go back to my README and let's see how I wanted to run this. I'll grab just the part that I care about and I will come down. By the way, if I look at my models, I can see that the type A model was built. So that finished running. It happens to be about half the size of my total model, which is kind of interesting. And it makes some sense because there's less data that is being used to train that model. But anyway, for this example here, I don't want to use my center type A. I want to do this for all of them. So I should be able to do type equals all and like this. And then I'll put in my new line. Okay. And what else do I have? I have a specific center ID. I have a specific meal ID. Let's see how it goes. Okay, it's a little bit mad at me because I have a syntax error. I'm sure a lot of you were yelling at me, but I just couldn't hear. Sorry. So if I come here and I look for that, let's hop in the lazy way and do it like this. All right, so I've got some code formatting. It's mad at me that it can't access these parts of my configuration. Oh, I know why. It's because these aren't configuration options. These were arguments that I passed and I never put them in here. So instead of doing it this way, let's do it this way. I'm not going to make them part of the config. I'm just going to pass them as variables into this function predict. They're going to be strings. So I'll do it like that. And now where I have them set up as config, I don't want these to be config anymore. So I'm just going to make sure I get rid of those. Although I need them here. And I need to say that they're strings. Okay, I'm happy with that. And then max week is also not defined. I put that in the config, so I need to update that. All right, now I'm not getting these errors. And I'm finally feeling like I'm making a bit of progress on this, and that's great. Now I will need, I'm not using this, I'm not using this, get rid of that. I will need to rebuild for this function. But first, I'm missing one more thing, aren't I? Because I'm not passing these in here. When I run my predict, I have to pass in the arguments, and they're from my arg parser. And what it was center ID and meal ID. Let's put them in here and do it the lazy way. I'll bring this up and say args, like that, get rid of string. Bring this up, args, get rid of string. Cool, okay, I'm ready to roll again. I'm gonna have to rebuild this. Whoops, okay, I think that worked. And then I wanna run it. And this was my run command, so let's do that. It can't import predict from ml.predict. Do I have, oh, I didn't call it predict. Okay, let's try that. So I never tested center type all. So if I get rid of that, let's see if it works now. It looks a bit upset because center type is none and it's trying to identify that model and it wasn't able to find that. The right way to deal with this, or at least a way, would be to come down here and where I say center type, I could say center type name prefix config dot center type. And I gotta be careful here. I want to underscore before, let's say, and then I'll get rid of this. And instead here, I'll say center type name prefix. Make sure that's working. So that way, and then I'll say, oh, you know, if config dot center type or, and then I'll just have it as an empty string. It's not or, it's else, like that. Okay. So this actually was a bad model ID. I don't have that model. This is a good model ID that I can use. Okay, so where did I do that? Down here, I just picked a bad one. This is a model ID that I actually have a model for. So it's upset because it wasn't able to find any samples to make a prediction on. Let's see why that's happening. This line here is returning nothing. Let's see, so is my center ID in my data, is my meal ID in my data, and is the week, max week in the data. So 177, 1445, 177, 1445. Maybe the problem is that this is not a string. So maybe if I call that an integer, it'll work. I also want to just print this index so we get a little bit of logger.info. Okay. Nice. So that was it. The problem, as you can see in my notebook here, is that I'm using integers in my notebook, but I was using strings in Docker. So when I cast those strings to integers right here, I was able to fix my error. I was able to identify the data that I wanted to make my prediction for, and I went ahead and printed out what that record looks like. Then I was able to make my prediction. And in this case, I'm seeing a number of orders as 42. So that's it. This video was pretty intense and pretty damn cool if you ask me. This is the type of stuff I love. And if you liked this video, I would appreciate it if you could give me a thumbs up and consider subscribing. This really helps me get my content discovered. And what I'm picturing now is that I want to create a course where I can really break this problem down in every aspect, like the exploratory data analysis, my feature engineering, my model designing. I can build different types of models and I can explain how those models worked. We didn't really even talk about the gradient boosting regressor that we're using and how that works on the inside, which is really important to understand when you start building these sort of things and making these types of systems. But lastly, I also want to build APIs so that we could deploy this and use this as a predictive system for our actual problems that we're trying to solve. If that sounds interesting to you, then head over to my Patreon and you can see if I've created that course. And if not, you could just sign up as a free supporter just to stay involved with my community for when I do create that. And you can also sign up for my Substack where I send one email a week as an alert for my new video that I've uploaded. I appreciate you spending some time with me today. Namaste.